if I was creating this worksheet, I would have put parentheses around that 5x. They intend for there to be parentheses around that 5x, but they did not put parentheses around that 5. Like, they're assuming that you know that that is a negative 5x, and because you can't just have log minus 5x. You have to have log of something. So there has to be parentheses. That has to be of negative 5x. But it looks like log minus 5x, which usually throws students off. And 5 is similar. You got negative 4 log base 3 of negative 9m. There. Let me look through and see if there were any more that were like that. Number 1, you put parentheses around the 4n, but most students would put that there, I think. I think that's all for these. So some of these problems that you're going to see are things that we have already done. So, for example, if we look at number 4. Okay. Number 4, we've got log A equals log of 4a minus 9. Okay. We've already done some of these. These are sort of the easier. I hesitate to use simple or easy because it's not always the same to everybody, but easier of the problems. Log on both sides. Everything's inside of the log on both sides. All you have to do here is drop the logs, right? So 10 to the power is technically what you're doing, but it just drops the logs from both sides. A equals 4a minus 9. You would subtract your 4a from both sides. Negative 3a would equal negative 9. Divide by negative 3. And a would equal 3. One thing I did not do yesterday, or on Wednesday, but you do need to look at, when you plug, remember we talked about the domain of a log. You cannot take the log of a negative number or of 0. So whenever you get your answer, you do want to look back at the original problem and just make sure that you're not getting negatives or 0 inside of the log. So here, if I plug in 3 right here, that's fine. It's positive. 4 times 3 minus 9 is 12 minus 9, which is 3, also positive. So this one is fine. But you may run into a problem or two on this worksheet. I should have to be looking at the answer key so I can tell you for sure. Where you got to throw an answer out at the end because it gives you a negative inside of the log. There. All right. You have some others that are also like ones that we have already done. So let's look at 7. For 7, you got negative 8 plus log base 9 of m plus 1 equals negative 8 here. Now this one is not a drop the logs problem because you don't have logs on both sides. So we did some of these as well. You want to get the log by itself, and then you've got to use exponents to get rid of that log. So for this one, you would add 8, and you would get log base 9 of m plus 1 equals 0. And then, Kendall, remind me what I've got to do to get rid of that 9 on that log, or that log base 9 there. Good. So 9 to the power on both sides. That'll cancel over here. I just get m plus 1 equals 9 to the 0 power. What is 9 to the 0 power? Is 1. Good. A lot of people want to say 0 there because it seems like it should be 0, but anything to the 0 power is 1. And so you would subtract 1 from both sides, and m would equal 0. Now, this might be alarming, like, uh-oh, we can't take log of 0 for this, but if I plug 0 back in, do I have a 0 or negative in the log? 0 plus 1, so it's still okay for this one. Okay? All right, so the front side is really all things that we have done before. They're similar to those questions you guys were solving for me on that other worksheet that we did Wednesday. Let's look at number 13, because that's when things start to get different. We got log x minus log 6 equals log 15. Okay, we're going to have to use the quotient rule here. You may be tempted to just drop the logs because everything has a log, right? But in order to drop the logs, you have to have a single log on each side. Because what you're doing when you drop the logs is you're doing like 10 to that power. And so this whole thing would be raised to that power, and it could cancel out maybe that first, but it can't cancel that second log there because you don't have two 10s on each side. So you cannot drop the logs until you only have a single log on each side. So we're going to use those rules that we were using yesterday to combine logs on each side. So this would be the quotient rule because we've got subtraction. So we would combine that and make it log of x over 6 equals log of 15. And now you just have a single log on each side. So you can drop logs. X over 6 would equal 15. How do I get rid of that 6? Multiply both sides by 6 because fractions are just division. So x is going to equal 15 times 6, which is 90. Okay. Let's look at 17 because 17 is going to be different. 17, we've got log base 4 of x squared minus 3 plus log base 4 of 10 equals 1. So when I see those two logs there on that side with the plus sign in between, I know I'm going to have to put those together. Okay? So when I put those together, I'm going to have log base 4 of, I got to do 10 times x squared minus 3. Like that, because we've got addition, which is going to be multiplication when we put those together. So we are multiplying the 10 and the x squared minus 3. So now I have combined everything to a single log on the left-hand side. But do I have a log to drop on the right-hand side? I do not. So I cannot drop the logs like I did on number 13. Instead, I've got to get rid of that log base 4. How am I going to get rid of that? 4 to the power. So 4 to the power on both sides here. That will cancel out my log. And so I'll have 10. Is that all right with you guys if I go ahead and distribute that? Yeah. 10x squared minus 30 is going to equal 4 to the first power, which is just 4. So if you got logs on both sides, you drop the logs. If you only have a log on a single side, you got to use those exponentials to get rid of that log there. All right, how do we solve this? Okay, we're going to add that 30. So I've got 10x squared equals 34. And then I need to divide by 10. So x squared is going to be 3.4. And then how do I get rid of a square? Square root. Okay, and when I square root both sides, so here's square root of 3.4. Is giving us 1.844 if we round it to the nearest thousandth. If I square root both sides, I'm supposed to put a plus or minus with that. However, I do want to check to see if it's okay to have a plus or minus, because sometimes those negatives cause us trouble with logs. So if I go back to the original problem, this x squared minus 3 has to be positive. So if I plug in 1.844, 1.84, I might actually need to check that. Let me pull my calculator up so you guys can see what I'm doing here instead of using this one. I need to make sure I'm getting a positive number here. So 1.844 squared minus 3 is going to give us 0.400336. That is positive, so we're good. Is it going to be any different if I plug in the negative? It is not. As long as you are good at typing it into the calculator, as long as you type it in the calculator correctly, we'll get that same number. Because you would have to do negative 1.844, close your parentheses, square it, minus 3. You'll get the same number. But, I typed it in wrong. Let's try that again. There we go. So you'll get that same number. Now, here's what students do wrong a lot of times. If you are squaring a negative, you cannot type it in like this. Yeah. I use the negative button, but this is still going to do it wrong. Because when you square something on the calculator, unless you put parentheses around it, it is only going to square what is directly in front of it. It is not squaring that negative. It's only squaring the 1.844, so that would not be correct. But these both give you positive, so both of those answers are okay. You got positive and negative 1.844. Let's see. We probably need to do 19. We got log base 5 of 3 minus log base 5 of 5x equals 2. So I've got logs that I need to combine. I have subtraction. Lee, what am I going to use to put those together when I have subtraction? Division. So it's going to be log base 5 of 3 divided by 5x equals 2. And then Maggie, if I've got that log base 5, how am I going to get rid of it? Good. So it's going to be 5 raised to that power on both sides, which will cancel out my log. So I've got 3 over 5x equals 5 squared, which is 25. All right, this is why pre-calculus is so great. This is some rational equation stuff that shows up in the middle of this because that x is in the bottom. So how do I solve this? What do I do with it? What were you wanting to do? Just like multiple. Yes, you can do that. So as long as you're multiplying by 5x. A lot of students want to like divide by 3/5. They leave the x in the bottom right there. We can't do that because you cannot solve for an x while it's in the bottom. So you got a couple options here. You could multiply by 5x on both sides, which will cancel this 5x over here, so 3 will equal 125x. And And then you just divide by 125. So x is going to be 3 over 125, or the decimal for that would be 0.024. So I don't even need the squiggle equal sign. Exactly that. So another way of dealing with stuff like that is like when you got 3 over 5x equals 25. This is also where you could like put that over 1 and cross multiply. That's another option. You'll end up with the same thing. But you cannot solve for a variable when it's in the denominator, so you got to multiply both sides to get that out of the denominator first. Okay. All right. Let's see. I'm pretty sure. Let me pull up the key to this, because I'm pretty sure that this worksheet is the one where they put e's in the answer for this, but I'm not going to do it unless it is. It's not this worksheet. It's this one. All right. Let me make sure. Oh yeah. You can see the answer key, like it left that as 3 over 125 instead of doing a decimal. What I would like for you to do on the worksheet is get both answers. You need to see that this is square root of 85 over, you can just type that in the calculator, make sure it matches your decimal is okay here. But on the quiz that we're going to have Monday, it is going to be on Canvas, and you're going to enter all of your answers as decimals. So you will not enter your answer like what you see here on number 22. But your answer key is like this, and it's good for you to know how to do it this way. So we're going to look at both ways to do it. But on the quiz on Monday, everything's going to be answered in decimal form for those. Or there'll be whole numbers for some of them. So you don't have to do this E stuff, but we're going to do it because, you know, I can't quiz and test you on every single little thing it would be good for you to know. So some things we do may not end up on the quiz, but many of them will. So let's look at, let me see, do I want to do, let's just go to 24. It looks the hardest. All right, we're going to do this two ways. Okay, so we got natural log of x plus 3 minus natural log of x plus 2 equals 5. Okay, so the first way I'm going to do this problem is the way we've been doing everything so far. And when we see natural log of something, we just go ahead and change it to a decimal. So the first way I'm going to do it is just using decimals, and you can do it this way on your quiz. So you don't have to, if it confuses you with the e's, the next way I'm going to do it, you can do it like I'm doing it here. So like the last problem, this is subtraction. So this is going to be natural log of x plus 3 over x plus 2 equals 5. And then, Abby, how are we going to get rid of that natural log right there? Yeah, e to the power, because your base on a natural log is e. So that'll give us x plus 3 over x plus 2 equals e to the 5th. I'm going to write it like that. Okay, here is where the two ways we're going to do this problem are going to differ. Right, so I'm going to write it over here as well. You may not have room. You just, so, with decimals, okay, with decimals, we're just going to type e to the 5th into our calculator. So, e to the 5th is 148.413. And I'm going to just write down 413, but I'm going to keep that whole number in my calculator. All right, so how do I solve that? Okay, we can cross multiply or just think of multiplying by x plus 2. You cannot solve for, if you have an x in the denominator of a fraction, you got to get it out before you can solve this. So either way you think about it, you can cross multiply, or you could think of doing it like x plus 2 and x plus 2 here. Either way, you're going to end up with an x plus 3 equals 148.413 times x plus 2. And then you just need to distribute. So x plus 3 will equal 148.413 x plus, I'm going to take, notice I'm using my number in the calculator and multiplying it by 2 instead of that rounded value. I'm doing it right though. So 296.826. And I would subtract this x right here. And then I need to subtract the 296.826. So 3 minus, on the calculator, if you want to, you can either store that value, or if it's on the last line, if you do second and the negative key, it'll give you the answer from the line before. So we get negative 293.826 equals 147.413x. It wouldn't have hurt if I had, I really should have stored that value there. I can still see the decimal though, so and I'm going to divide by 147.413. And I probably should have stored this value right here so I could have the exact decimal, but I'm just going to divide by 147 point, and I'm going to use as much as I can see of that decimal, 413.1591. Or you can just like not be lazy and write the whole number out as you do the problem. And we get negative 1.993. Is our x. Which is a negative number, but if I plug it back in, does it give me negative numbers up here? It does not, because it is smaller than the 3 and the 2 that is added to it. So this on your quiz, this is what you're going to type in for me. So you will type in your decimal like that. Yes. When we subtracted this x right here, it was subtracting a 1x right there. So we subtracted 1 from that value. Okay? All right, questions on that? All right, now let's do it the other way. On this, to look at this. Okay. It's okay. Sometimes I skip ahead a little too fast. Okay, so if we solve this problem using e's instead of using decimals, everything is really still exactly the same. We're just using e to the 5th instead of using decimals. So this is what that would look like here. Just like I did on over here, I would multiply by x plus 2. Okay, that would cancel my x plus 2 out. I would have x plus 3 equals e to the 5th times x plus 2. just like I did for the problem over here, I would distribute my e to the fifth. But I'm just not using decimals yet. So x plus 3 would equal e to the fifth times x plus 2e to the fifth. Okay, so now you need to move your x like we did. So we need to subtract this x. This is where things get a little bit weird, right? Because we're have e's instead. So I've got 3 equals, I can't really put e to the fifth and 1 together because they're not both in terms of e. So the way I have to write this is like this, e to the fifth minus 1 x plus 2e to the fifth. So if you get, like I could do that in the calculator because e to the fifth is just a number. But I can't do it if I'm still using the e's because they're not the same. So you're just going to put parentheses around it there. Then I want to subtract that 2e to the fifth. Can't put those together either, so I just have to write that 3 minus 2e to the fifth equals e to the fifth minus 1 times x. And then I want to get that x by itself. This stuff is multiplied by the x, so I'm going to divide by e to the fifth minus 1. So you get x equals 3 minus 2e to the fifth over e to the fifth minus 1. Now, if you understand this well, you can do it that way faster than you can use your calculator because all the decimals and losing, rounding and all that stuff, and you're probably also much more accurate. But if you're not comfortable with that e, it can be a little bit tricky. Our answer key is going to give us the answers like this. You can even see my answer key looks a little different than what I've got here. They have answer key right here. Let's zoom in. They've got negative 3 plus 2e to the fifth over 1 minus e to the fifth, which is close to what I got, but all the signs are changed, right? I have a positive 3, I have a negative 3. I have a negative 2, they have a positive 2. I have a negative 1, they have a positive 1. I have a negative 5, they have a positive e to the fifth, they have a negative e to the fifth. So this is, mine is still correct because if I multiply the top by negative 1 and bottom by negative 1 of what I've got, it doesn't change the value here. So mine looks different than what they have as the answer, but it is still correct. You can, if you do it this way, you can always type it into the calculator to see if it's the same decimal. So like 3 minus 2 e to the fifth. Make sure you put parentheses around your numerator and parentheses around the denominator, or it won't do it correctly. So you can see I get the same decimal I had over there. If I type in this one, negative 3 plus 2 e to the fifth divided by 1 minus e to the fifth, I get the same decimal as well. So they're the same, they just look a little bit different. I'm purposefully not going to give you the decimal answers for these last 3 because it's up to you whether you want to solve it with decimals or solve it with e's and then check. But I want you to be able to type this into the calculator and see if you're getting the same thing as the decimal that you got there. So I'm purposefully not giving you decimal answers for those there. I think that's going to pretty much cover everything that you need to know for this worksheet. And let's see, we get out here at 12:10. I think we're going to hold off on our game because we're not going to have much time, even if we start a little bit of it. And we may play it at the beginning of class on Monday, as we might do that instead of a warm-up, kind of as to get us back in the swing of things before we take our quiz. So your homework is going to be to finish this worksheet, but you've got about 18 minutes right now to work on it, so hopefully you can get a lot of it done before you go. Also, what we're going to do on Monday, our plan on Monday, is we will probably, instead of a warm-up, we might play our knockout game that I was going to play today, just for a few minutes. And then we will, if there's any questions on the homework, we'll look at those and we'll take our quiz. After the quiz, you guys are going to have a short set of notes on interval notation. And I'm not going to give notes. I have recorded it, and you are going to watch it on Edpuzzle and fill in your notes. And Edpuzzle has like a few questions you have to answer as you do it. So bring either earbuds or a set of headphones or something that you can use with your computer, because if you finish the quiz early, you can go ahead and start it. If the quiz takes you till the end of class, it'll be your homework and you can do it from home. Okay? But be prepared. Hopefully you'll get time to at least start it. It's only like 15 minutes, so it shouldn't be super long. But bring that.